Hello and welcome to my YouTube channel. Today in this video, we are going to talk about the basic concepts related to RTOS. So without any delay, let's start the video. First of all, before starting the course related to RTOS, one must ask few questions and one must know few things related to the RTOS. First thing, there are several real-time operating systems available in the market. So now the question is, based on this knowledge, how can one select the most appropriate RTOS or software for his or her applications? Basically, industry and experts choose most appropriate RTOS from their personal experience and demand of the project. But in this course, we cannot go and cover all the RTOS which are available in the market. So in this course, we will be talking about free RTOS. We will be using the free RTOS to design our projects and implement the real-time applications using hardware. Why we are going to use free RTOS? This might be a question because there are other alternatives available. In this course, we are using free RTOS because this is free. Anyone can use free RTOS, and free RTOS is designed and updated regularly. So you will get the most updated free RTOS free of cost, and it is also supported by world's most leading chip companies. When I say chip companies, the most leading microcontrollers and microprocessors. And this OS or FreeRTOS is available in the market since last 15 years. Secondly, FreeRTOS is almost equivalent to commercial grade RTOS, but it is completely free and therefore we are opting for FreeRTOS. It is a class of RTOS that can be designed to implement very small programs and projects, and even we can deploy the codes on microcontrollers or microcontrollers with very limited memory or very limited resources. So it is very flexible to use in day-to-day programs. Thirdly, FreeRTOS provides the core real-time scheduling functionalities, inter-task communication, timing, and real-time kernels. So looking into all these features, we have opted to cover the RTOS in this course using free RTOS. But before moving into the RTOS, there must be a question. Do we really need an RTOS for our embedded system or to program our embedded systems? So the question is not that simple. Before designing any system, the user must check that can he design the project without using RTOS or not. Because it is not necessary that all the projects that you design in your normal life needs RTOS. Because RTOS by nature impose software architectural structures, programming interfaces, and footprint constraints that sometimes your project may or may not need. Too often, the embedded system designers commit to an RTOS even before fully evaluating their needs. and considering wide range of options before them. So don't be in a rush before jumping into RTOS. First, you should ask few questions before starting with RTOS. Some of the questions which can be generated or asked are: do we really need real-time operating system? And if so, then how to choose real-time operating system? Second, how much the RTOS will cost if you are going for a commercial RTOS? And does your RTOS supports your board support package? And if so, how much does it cost? And what is the separation kernel? Only after answering all these questions and getting an appropriate answer, one should opt for RTOS for his or her project. Now, let us talk about the real-time operating system and their features. Like described in the last class or last lecture, the operating systems are specifically designed for real-time applications. So this word is very important. They are designed for real-time applications. That means they can process data and events that have critically defined time constraints. So until unless there are time constraints related to any particular project or system, one shall not go for RTOS. And definitely if he is opting for RTOS, then the system or the designs must be very critically defined for time constraints. Second, in RTOS, all the processing must be completed within defined time constraint. So all the processings that you do in the RTOS must be completed within a defined time constraint, or not constraint, within a defined time slot. RTOS is event driven and preemptive. Preemptive means one task can preempt another task. I will come to these topics when we'll be generating projects and see how these terms will be used in the projects. Now, RTOS is event driven and preemptive, meaning this OS is capable of monitoring relevant priorities for completing tasks. So you may have multiple tasks, but tasks with higher priorities generally will be running more or first compared to the other tasks with lower priorities. Apart from that, in RTOS, switching of tasks are based on their priorities, but not on the basis of time. So whenever you are designing a system, you will have to define the priorities first. And based on those level of priorities, the task will run. Remember, tasks do not run on the basis of time in case of RTOS. Systems designed using RTOS are not necessarily very fast. Remember, if you believe that if you are going to use RTOS, then your system will be running very fast, then it is not true. Systems designed using RTOS are not necessarily very fast. Why? Because here speed is not the major thing that we keep in mind. The most important thing is all the processes should be done in a timely manner rather than in a speed basis. Okay, so we have to complete all the tasks in a particular time rather than running all the programs in a very fast manner. So systems designed using RTOS are not necessarily very fast, but they all do their task in a timely manner. RTOS can, that means an RTOS can, if used in the right way, provides very precise control over allocation of CPU time. This is very important because in this we actually are allocating different times of the slots, different time slots of the CPU to different tasks, and we have a very precise control of the CPU time that will be allotted to different tasks, and hence render an application entirely deterministic way. But there is one factor that can get on the way, that is ideally interrupts. So if you are not good in handling interrupts, then be careful before using RTOS. You have to have a very good concepts or very good fundamentals related to interrupts, then only enter into RTOS world. Now let us try to understand the tasks in RTOS. Basically, the task that RTOS do is more or less similar to the task that we do in our daily life. Let us take an example. In our daily life, we wake up in the morning, we have our breakfast, we will travel to our office or school or college, then do our work, then we take our lunch, and by the evening we may take some time out of our normal life, go for gym or playing some games. Then by the evening we sit together with the family, have a dinner, and in the night we take some time out to further study something. In general, this is the normal day to day life of a person. And in day to day life, these are the some of the common tasks that a human being or a normal person do. Similarly, the RTOS also takes care of similar tasks and perform them in a timely manner. So, how we can know the performance metrics of an RTOS, or on which basis we can say one RTOS is better than the other or not? Basically, there are three areas of interest when you look for the performance and usage characteristics of an RTOS. First, the memory. Always remember, when you are using RTOS, you should keep an eye on the memory, like how much ROM, how much RAM does the kernel need, and how this affects or is affected by options and configurations that you use in your project. In simple, you must keep an eye on the memory management. Second, latency, which is broadly the delay between two or more than two events. So you have to keep an eye on the time the events taking or the time by which the events complete their job. Second, after the latency, third most important parameter is the performance of the kernel services. What does that mean? It means how long does it take to perform a specific action or a specific task. So based on these three performance metrics, says we generally compare the RTOS, or we generally measure the performance of RTOS. But last but not the least, reliability can be considered one more parameter. It means, here reliability means running a task in a predictable way with guaranteed response within a specific time. I should have added within a specific time here. So reliability means how many times the task will run without any error within a specific time period. Now, before entering into the world of RTOS, we must understand what we are using in our day-to-day programming. For our programming, we generally use super loop concept where we start the program, we initialize some variables, and might be possible we read some inputs or we take some input from some of the pins of the microprocessor or microcontroller. Then based on the input, we make some decision, right? And if the decision is not met, then we go back, read the data again, and so on. If the condition is met, then we go down and read the second pin, and so on. And our function goes back. So this way, in the super loop, you can see here the program is running like this always. Okay, you are going back to the 0. So this is the normal way in which we generally write our programs. This is called super loop. Now, instead of using this approach, in case of our RTOS, we generally divide these tasks into multiple smaller tasks and we run these tasks. For example, task number 1, reading pin number 2 and doing some event based on the input received from pin number 2. Task 2 can be considered reading the pin number 1 and based on the condition doing or taking some event. Third, maybe some functions to add or subtract or to do some signal conditioning, and similarly task 4 is also related to some signal conditioning. So in the left we have the super loop and in the right we have the approach that is taken by the RTOS. So we break these chunks of super loop into smaller tasks and we run these tasks independently in RTOS. So this is the major difference between super loop and RTOS. For example, this is the way how the super loop is broken down to different tasks and the RTOS run these tasks, and it appears that these tasks are running concurrently or they are running simultaneously together within a specific time period. Although it looks like all the 3 tasks are running simultaneously, but in actual world or in the real world, these 3 tasks appears to be running concurrently, but in real world they take their own time, and then one task is completed, then only task 2 will be running. After task 2 completed, task 3 will be running. But these 3 tasks or so on, multiple tasks run so fast that it appears that all of them are running simultaneously. Like this in our case. It looks like if they are running too fast, then it appears that all tasks 1, 2 and 3 are running simultaneously, but this is not the reality. So what we are doing here is we are breaking down the super loop to smaller tasks and running all these tasks on a timely manner. So here each task appears to run concurrently in its own while loop. Okay. In microcontrollers, we can also set up independent interrupt service routines or ISRs that can preempt any of the tasks to execute some other codes. This we will see or we will go through many such examples in which we will experience how the interrupt service routines are handled when a particular task is running. With this, I would like to end this presentation. If you have any doubts or suggestions, please share your doubts and suggestions in the comment section. And if you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the notifications as soon as I upload a new video. Thank you and have a nice day.